Hello everyone. In this project, I built a machine learning model to predict the net hourly electrical energy output measured in the megawatts of a combined cycle power plant. So this is our project. A combined cycle power plant generates the electricity using the gas turbines, steam turbines and heat recovery. Uh, st- uh, the power output is influenced by the ambient environmental conditions which are continuously measured using the sensors. The goal of this project is to accurately predict the electrical power output using historical sensor data. So the data we have is the total 9568 hourly observation collected from the real power plant, and each records include the temperature, then ambient pressure, then relative humidity in the percentage, and the exhaust vacuum in the centimeters of mercury. So in this way the target variable is net electrical energy output in megawatts, which ranges roughly from 420 to 496 megawatt. This is a real industrial data source from the published research. And now I have created the Python file in which so this is the supervised machine learning regression problem because we are predicting a continuous numeric value. So to evaluate the model performance, I selected RMSE root mean squared error as the primary metric, and because it measures prediction error directly in the megawatts. I also report the R squared, which shows how much variance in a power output the model explains. These metrics are well suited for the engineering and operational forecasting problems. So here we just check the feature selection and the candidate model. So I use all four sensor reading as a feature since each has a physical relationship with the plant efficiency and the power generation. So I compared multiple models, the ridge regression, including a version with polynomial features to capture the nonlinear relationship, then random forecast regressor, a nonlinear ensemble model that automatically captures interaction between the variable, and this allowed me to compare a traditional linear approach against a more advanced machine learning model. So I split the data sets into the 88% training data and the 28% test data. The test data was set, held out and used only once at the end of our final evaluation. On the training set, I used five-fold across validation to compare models. This ensures a fair and reliable comparison by reducing the risk. So the model comparison and the final selection, we have the random forest regression consistently archived the lowest RMSE, indicating better predictive performance than the linear model. So based on this validation performance, I selected the random forest as the final model. The final test set performance after training the selected model on the full training set, I evaluated it on the unseen test data. So let's check the this is my Python file in which I use the NumPy library and the pandas library where we are using the sklearn. And when I execute this, let me execute this. So it is executing. So you can see here it is executing. To conclude this project, demonstrate how machine learning can be applied to energy forecasting and the operational optimization. So here it is improve the efficiency, accurate power output prediction can help plant operators improve efficiency, plan load distribution and reduce the operational risks. You can see here the R square is the 9.9641 and RMS is 3.228. So this is my result, and the in the reach poly degree to CV RMS is 4.312 megawatt, and random forest is the 3.443 megawatt. So in this way we have executed the project, and this is my project output. Thank you for providing all the trainings. It helps me to understand the machine learning project for the product management. So you can see here the final metrics are displayed here. Thank you very much.